So let's talk about Fstatistics and p-values in one-way ANOVA. Let's return to the ABC, where the quality engineer is comparing fiber strengths to ensure that only the strongest nylon is used in the manufacture of its automobile safety belts. In the previous lesson, we formulated hypotheses about nylon fiber from different suppliers. The null hypothesis states that the mean tensile strength uh, for each supplier is the same. The alternative hypothesis states that the mean tensile strength for at least one supplier is different from the others. We can use one-way ANOVA to test the hypothesis. ANOVA compares the different sources of variation to determine whether groups are significantly different. Earlier in this chapter, we learned about between group and within group variation. The individual value plot of strength versus supplier suggests that the between group variation may be larger than the within group variation, but is this difference statistically significant? We can compare between and within group variation with the F statistic. The F statistic is a ratio, so when F is larger, between group variation is larger than within group variation, which indicates a real difference between group means. When F is small, the between and within group variations are similar, indicating that there is a little or no evidence of a significant difference. So, should we reject the null hypothesis that the mean tensile strengths are the same? We use the p-value. We use the p-value to answer this question. The p-value is the probability of obtaining an F-statistics at least as extreme as the actual calculated value, given that the null hypothesis is true. If the p-value is greater than alpha, we fail to reject the null hypothesis. If the p-value is less than or equal to alpha, we reject the null hypothesis. Remember, you will need to use the p-value from the ANOVA output to determine whether the main effect is statistically significant. For our ABC study, we'll use the most common value of alpha for ANOVA 0.05. The output indicates that the p-value for this study is 0.00. So, should we reject our null hypothesis? The mean tensile strength for at least one supplier is different from the others because the p-value is less than alpha, so the results are statistically significant. Let's review. We learned how to use the p-value to interpret ANOVA results. If the p-value is greater than alpha, we fail to reject the null hypothesis. If the p-value is less than or equal to alpha, we reject the null hypothesis. Thank you for your listening. In the next lesson, we'll talk about the multiple comparisons.